This is an airgun project that I was thinking about doing, and this is a valve that I wanted to try to make just as a test for that project. And so what this is it's a, well, I call it a slide hammer valve. And so the hammer, instead of pushing on the valve, um, the hammer is going to pull on the valve. So the hammer is going to slide on the valve stem, come back here, hit this washer that's on the end of the valve stem, and yank the valve stem open like that. And what I'm hoping this will do is this will give the air an unrestricted and straight shot uh, down through the barrel. So the tank, I'm going to make that from 2.5 inch, 1/4 inch wall seamless chromoly. And the end plugs here, just going to make those out of aluminum. And they're going to be held in place by, I'm going to do eight, eight quarter 28 screws. I only have one drawn in here right now, but there's going to be 8 of them though. And in the end plugs, I'll have a O-ring, have an O-ring groove here, so to seal to the tank. And the valve stem, I'm going to make out of drill rod, probably like 3/4 inch drill rod. And then the valve head, I'm going to make out of Delrin. And the valve stem, I'm going to make that almost the same size as the sealing part of the valve head. That way it'll be a what they call a balanced valve, so it won't be as so hard to open. It won't have as much air pressure holding the valve shut. And then I got these 2 O-rings in here, which are going to seal the valve stem to the tank caps there. And then this is just going to be a big, like 2.5 inch cold rolled steel that I'll just drill a hole in, that'll just slide on the valve stem as the for the hammer. And I think that's about it. So yeah, so I'll build this thing, and we'll test it and see what kind of numbers we can get out of this. To pull the hammer back, I'm going to use an air cylinder. That way, the air cylinder will be both the spring and the trigger mechanism. That way I don't have to make a trigger mechanism. And I can also vary the spring rate by just changing the air pressure. So I was looking around my shop trying to find something interesting to shoot out of this thing. I saw my pen and pencil laying there on the table, and thought it would be interesting to see which could penetrate deeper into wood, a pen or a pencil. So I wanted to weigh these, that way I could calculate how much energy that they're putting out. This is one of the only projectiles that's capable of drawing its own target. I got one of these Airgun pumps off of eBay. It's a cheap way to get up to 3,000 psi. However, it is a bit of a workout trying to get your tank up to 3,000 pounds.
That's crazy. Wow.
Pin did more damage to the first board. It's the one on the bottom with ink splat next to it. Then they both punched through the second board. The third board stopped the pen. There was nothing but an ink splat. The pencil made it through the third board and then just left a graphite splat on the fourth board. Both the pen and the pencil just completely disintegrated. I never even found one little piece of them. So going in my ballistics calculator, I put in my 130 grains, which is my 8.5 gram dart that the pencil weighed. And then coming down here, I entered in my 1933, which is 1933 feet per second, which is what the pencil got. And so that gives me 1078 foot-pounds of energy, 1,078 foot-pounds of energy, which coming over here is pretty close to what a 223 puts out, just a tad less.